All right, so the next thing is SSTI. This is a command injection attack, but it's interesting because it works based on how Python works. So if you look at a modern web page like Amazon, you go to Amazon.com and you don't see the same page everybody else sees. Now, decades ago in the early web, you would just put up an HTML file and everybody who goes to your page would see the same HTML file. And that's the way it used to be. But now you have a template for your website, and the template includes fields that fill in from databases and cookies and the IP address of the customer and whatever. So they each have a customized page. And so that's a template. And it turns out these template languages tend to be vulnerable to code injection, and some of them are written in Python 3. So you can set up this server to run this page, and I'm running a vulnerable version of it here. So this is a place, if I search for a user like Joe and search, it will always tell me it found Joe because there is no database. It just always tells you it can find whatever you're looking for. But the interesting thing here is if I insert something in double curly braces, like 1 + 1, double and close double curly braces, I get user 2. So there are certain fields that are intended to be filled in by the server, but they do accept data from the client and process it. So there's a command injection here. I can inject code in those curly braces and it will be executed on the server, just like Bash command injection or SQL injection. It accepts some degree of code from me. So you can now exploit this thing and you can get away with murder far more than you would think. So let's shove this over to the side and talk about how to exploit it. So here is the basic flowchart to fingerprint a server. So if I want to find out what kind of server I have, there are several engines that can have this flaw. I put in this dollars curly brace 7 + 7. So dollars curly brace 7 × 7 end curly brace. Okay, if you run that, it does not evaluate that expression. It just treats it as a literal name. So that is, you need to follow the red arrow. That injection failed. I did not get it to execute the code. So I'm down here somewhere. So I've tried double curly braces and no dollars. And as we saw before, that one's going to work. Now I get 49. So that was true. So I'm up here. So if you follow the flowchart, you'll find out which template engine it's using, and in fact, it is Jinja 2. Now, Jinja 2 is written in Python 3, so the first thing you would imagine is now that I can inject code, I'd be able to run libraries that the developer imported into their Python application. Remember, when we import a library, you have to have an import statement, and if you don't import a library, you can't use that function. But it turns out that I can do anything with code injection. I can import new libraries while it's running that the developer did not want to put there. And that's because of inheritance in Python. Python is an object-oriented language. Everything you make is an object and it fits in a tree. So let's play with this. Python 3 in interactive mode. Now I can make a string. So I can just put here hi. And I can do, as I did before, a directory of S to see what can you do with that string. And it turns out that a string object has a lot of attributes and methods. You can do a join, you can do some kind of find and change it to uppercase and things like that. And that might be fine, but it also has something called class. Now class will tell me what type of object this is. So I can do S dot underscore underscore class underscore underscore. So this is a class string object, not very surprising. Okay, but now I can walk up the hierarchy. If I can do S class, I can then do the class of that. And that is a type. So string is a string, and the class string is a type. You can also use the base command to walk up the hierarchy. And if I do that, I'm now up to object. So here's how it looks. I start with a string. Let me shove this out of the way. Then above the string is the class of this object, and the class of that is type, and the base of that is object. And when I get to object, I'm at the root of the entire Python tree. So I can walk up to the top, and then I can walk back down from that object and go places the developer never expected me to go. And what I do is I go to subclasses and warnings, because the warnings object has a method called import, and I can now import OS system, which the developer did not import. Just by letting me put in a string, I can add these special commands to the string, which turn the ability to fill in a string, like putting a username or password, into the ability to import a library into the code, which is crazy. So now you can, so with a long attack, you can import your own library and get bash command injection from inside the template. So it's bloody awesome and a lot of fun. So you can play with Python 3 just to see it go, and then you can take over a server with it. I'm running a vulnerable server. You can make your own vulnerable server, and you can attack it, and then you can attack my vulnerable server and get a flag off it, a couple flags on my server, and you will have to inject long things, sort of like this mesh, to walk up the hierarchy, walk back down, import OS system, and then you can execute bash commands like ls and so on. So you can eventually execute bash commands on my server and find the flag and print out the flag. So it is pretty mind-boggling. And of course, one defense is to just filter input and not let people put in the special characters and such. But just like SQL injection, if you just take data from the user and put it in something that seems harmless like a string, it can turn out to be very, very dangerous and give them code injection on your server.